Okay, so can everybody see my screen? Okay, so I'll move on. Today will be the last class, and it's about more counting techniques like stars and bars and complementary counting. So, I'll do homework review first. So, for the first one, there are 9 parking spaces in front of the school for 6 teachers and the principal. If the principal always gets one of the 3 spots closest to the door, how many ways can all 7 cars be parked in a lot? So, there are 1, 2, 3, 4, 5, 6, 7, 8, 9. Suppose the door is right here. The principal can choose which three of these parking spaces he or she wants. So, there is 3 ways. And then for the rest, there are 8 spots left. And we will have to choose 6 for the teachers. And since all the cars are different, it's 8P6, which is just 60480, I think. Questions? If none, then I'll move on. So, how many ways can you get from this square to this square? And it's not this point to this point. It's a square to the square by only going up or right. So, like that, there will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 ways for like there are like 11 U and R's. And there are just 11 choose 5 ways to order these numbers. So it's 11 times 10 times 9 times 8 times 7 over 5 times 4 times 3 times 2. These two cancel. This cancel with this. This cancel with this. And it will give us 330. Wait. 1, 2, 3, 4. Sorry, it's 4. So 11 choose 4. 11 times 10 times 9 times 8. 4 times 3 times 2. These two cancel. 330. Questions? If none, I'll move on. So, we will first cover complementary counting, and then stars and bars or sticks and stones, whatever you call it. Okay, so the concept is pretty simple. We just find suppose we want A, number of ways for A to happen. And suppose there's a B such that the number of ways that A and B happen equals to the number of ways the total happens. Then we would just have A equals T minus B. It is like usually used in problems where the total and the what we don't want it's easier to find than what we want. So, just like this, 1 plus 2 equals 3, 1 equals 3 minus 2. As simple as that. So, I'll give you guys a few minutes to solve these two. Okay, so I'll go over it now. So for the first one, how many 10-unit passes from A to B do not pass through X? So elementary counting easily. We can also do this using casework, but it would be really, really complicated. So complementary counting is the key to this problem. So total number passes from A to B without restrictions. And then the complement is the ones that pass through X. So there are total 10 steps and there are 4 U's. So there will be 10 choose 4, which is 10 times 9 times 8 times 7 over 4 times 3 times 2. These two cancel, these, that, 210 total amounts. And for the complement, we just find the amount of ways from A to X and then from X to B and then multiply them together from the counting principle, the fundamental counting principle. So there are four choose two ways to get from A to X times 10 choose, six choose two ways to go from X to B. So this is 6 times 15, which is 90. So the one that we don't want will just be 210 minus 90, which is 120. And for the second one, Paul flips a coin 8 times. How many ways can we flip at least 2 heads? So first, there are 2 to 8 ways for the total amount of combinations with the coins, because each coin gives us either a head or tail. So it's just 2 multiplied 8 times, or 2 to the 8th. And then we have to minus the ones where he flips 1 head or 0 head. So 1 head, A choose 1 ways, 0 heads 1 way. So this is just 256 minus 8 minus 1, which is 147. 247. Questions? None. I'll move on. And you guys get a few minutes to solve this one. So just do the first problem. Okay, so I'll go over it now. So for this problem, we have a fair coin is flipped 10 times, and we're asked to find the amount of ways such that we can flip more heads than tails. I will show two ways to solve this problem. The first way, just to do casework on the number of heads and tails, it will give us 10 to 6 heads, or we would choose four of the flips to be tails. If there are 4 tails and 6 heads, 10 choose 3 ways similarly, plus 10 choose 2, plus 10 choose 1, and then plus 10 choose 0. So this would equal 10 times 9 times 8 times 7, 4 times 3 times 2, 210. This is that. This equals 10 times 9 times 8 over 3 times 2, 3, 4, 120. And then this is simply 45. This is 10, and this is 1. Adding them all together, we should find 330 plus 45 plus 10 plus 1. So it would be 386. That's the first way to solve this problem. And the second way would be using complementary counting. So the key to doing complementary counting is that we want the amount of ways such that its head greater than tails. And since the coin is not weighted, the number of ways such that heads there are more heads than tails is the same as the number of ways there are more tails than heads. So suppose there are q ways, tails greater than heads are also q ways, and then tails equal heads are p ways. So there are total 2 to 10 ways, because each flip can either be there are 2 options for each flip, heads or tails. So 2 to 10 minus p over 2, because 2 to 10 the total minus this will give us 2q, and we want to find q, so we have to divide q. So we have this. We can find p easily. 10 choose 5 ways to choose the there are 5 ways to choose the where the heads go. So this is 10 times 9 times 8 times 7 times 6 over 5 times 4 times 3 times 2. These two cancel. These two, 3. So it should give us 252. So 1024 minus 252 over 2 is just 512 minus 126. So it would just give us, should be, yeah, 386. Questions? None? Then I'll move on. So this is just stars and bars and sticks and stones. So we're gonna go over stars and bars. So stars and bars is a useful trick that allows you to represent partitions with combinations. So suppose we want to split it's just similar to the number of ways to put two identical balls into n different boxes. So why is that? Because so suppose there are n spaces and like that. So we just put the Q in any way such that there is, we just put like the Q balls in any way, and the way that it will be the number of balls in the first part will be the number of in the first box, and second part second box, third part third box, all the way nth part and nth box. So stars and bars is just basically that. So give you guys a few minutes to solve this one. Okay, so I'll go over this one now. So, Uncle Henry has 10 $1 bills to distribute to his 5 nieces and nephews. How many ways does he have to distribute them? He must give each of his niece and nephew at least 1 bill. So, we have, suppose that the $1 bills are the balls or the stars. So, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there are 5 minus 1 bars because we need 4 bars to split it into 5 portions. So 1, 2, 3, 4. Looks like there are 14 choose 4 ways to divide these. But this is not the case because suppose we just have this case. 10 will go to the first one and then the rest will have 0. But remember, all of the nieces and nephews must get at least 1 bill. Therefore, we must first give 1 bill to each of them, and this will subtract 5 stars from the list, so it will only be 9 choose 4. So 9 choose 4 equals 9 times 8 times 7 times 6 over 4 times 3 times 2. These two cancel. 2. 18 times 7, 56, 126. Questions? No, then I'll move on. So, stars and bars is just plain bars. The bars you separate the stars into categories. As I mentioned earlier, you can just use combinations, and you might need to sometimes modify the concept by removing some stars or using complementary counting. So, I'll give you guys a few minutes to solve this one. These two, actually. Okay, I'll go over this problem now. So, how many ways can we roll a sum of 7 with 3 six-sided dice? So, for this one, we find that 1 plus 1 plus 5 can be there, so we won't have to use complementary counting. So it's just 7 stars, 1, 2, 3, 4, 5, 6, 7, and then 2 bars. But we need to minus a 3 from the stars. We need to minus a 3 from the stars because each must be greater than or equal to 1. So it would be a 6 choose 2, which is just 15. And then for the second one, how many ways to roll a sum of 13 on 3 10-sided dice? This we will have to be careful because our stars and bars will count this one. 1, 1, and 11. But 11 won't be on a 10-sided dice, so we will use complementary counting. So first, using stars and bars, we find that there are 12 choose 2 ways, which is 66, and we have to minus 3, where it's 1, 1, 11, 1, 11, 1, or 11, 1, 1. Minus 3, 63. Questions? None. I'll move on. So this will be the last 2 questions of the day, and I'll give you guys a few minutes to solve it. Okay, so I'll go over these two problems now. So, for the first one, how many ways can 12 pieces of candy be distributed to 5 children? So, we would have 5 minus 1, which is 4 bars. And since this problem doesn't need us that each kid gets at least one, then it would just be 16 choose 4, because it's just 12 times 4, 12 plus 4 over choose 4. So this is 16 times 15 times 12, 14 times 13 over 4, 3, 2. So 4, 5, 7 should equal 1820. And then for the second one, 6-sided die is rolled 4 times. How many ways can we roll 9? So we can find that we won't have to use complementary counting, because 1 plus 1 plus 1 plus 6 equals 9 perfectly. So all of the cases in stars and bars will be counted. So we can just use stars and bars now. 3 bars, 9 stars, and then each must get at least 1. So it's just gonna be 5 stars and 3 bars. So 8 choose 3. 8 times 7 times 6 over 3 times 2. These two cancel, 56. Questions? If there are no questions, then that's the end of class. But before I end the meeting, William will have an announcement to make. So go ahead, William.
All right, so yeah, this is the last session, but we're offering another 6 weeks of AMC8 class starting on Saturday, November 9th and September 9th, sorry. Going weekly for 6 sessions. And I'll be teaching this class, and more information will be sent out later. A little bit about myself. Currently, I'm a senior in high school, done math competitions since middle school, and I've qualified for the JMO and USMO in case you're curious. And this class, in addition to using the same Google Classroom, will be held on another platform. So if you're interested, keep an eye out for that announcement, as that will have all of the information on how to sign up and participate, etc. Thank you. And yeah, that's all.
Okay, so I don't think I have any more stuff to cover, so if you guys want to leave, you're free to leave. And thank you for your participation in these sessions. Bye. You're free to go. Bye-bye.
Bye.
Bye.
Appreciate y'all. See y'all next time.